Good morning, dear students. Today we'll discuss about the reverse osmosis. In order to understand the reverse osmosis, what is meant by potable water? So, the water which meets all the parameters of pure water and fit for drinking are called as potable water. Now the water which should be fit for drinking, it should be free from all the kinds of impurities. The impurities which you have enlisted in the previous class, that is dissolved salts, suspended impurities, inorganic impurities, organic impurities, dissolved gases, and these impurities should be free, and it should be not only free from the impurities, it should be clear, and it should be colorless, and it should be odorless, and it should be free from pathogenic microorganisms with an agreeable taste. So such water is called as a potable water. Now in this potable water, the process of getting pure water from the saline water, salt water, is called as an desalination or a desalting process. Now the desalination is a process, either the salt is removed completely or maybe sometimes partially. So the process of partial or complete removal of dissolved salts from the saline water, seawater, and water becomes potable. And this process is called as desalination. And this desalination, the process of complete or partial removal of the salts, will be achieved by one of the process called as reverse osmosis. Now, in order to understand this, now what is the definition of reverse osmosis? The process of movement of water through the semi-permeable membrane from higher concentration, that is from the salt side, to a lower concentration, that is to the water side, with the application of a greater pressure than the osmotic pressure, is called as reverse osmosis. Now, during osmosis process, when you look into this figure, uh, let us consider a vessel which is separated by pure water and the salt water. So salt water is said to be in higher concentration. Pure water is said to be in lower concentration. So when you separate these two water with the help of a semi-permeable membrane, the movement of water molecules from water side to the salt water side takes place. So that movement of water molecules from water side, that is lower concentration, to the salt water side, that is to in higher concentration, that movement is called as an osmosis. So osmosis is the movement of water molecules from water side to the salt water side through the semi-permeable membrane. So the pressure which is acting on the water side to make the water molecules move from lower concentration to the higher concentration, that is salt water side, that pressure is called as an osmotic pressure. Now, this movement of water molecules from lower concentration, that is from the water side to the salt water side, takes place as long as the osmotic pressure acting on the water molecules is equal to the hydraulic pressure or hydrostatic pressure. So the when the osmotic pressure equalizes the hydrostatic pressure, no more movement of water molecules from the water side takes place to the salt water side. So that entire process is called as a reverse osmosis. Now in the case of a reverse osmosis system, which contains usually a semi-permeable membrane, which is made up of either a cellulose or maybe artificially prepared polymer, usually polymethyl methacrylate, or a polyamide membrane, polyamide membrane, will be placed between the pure water as well as the salt water. So the saline water is applied with greater hydrostatic pressure for about 400 psi with the help of a piston on the salt water side, so that the water which is present in the salt water is forced to move across the semi-permeable membrane. So this the forceful movement of water molecules present in the salt water to the water side, that is from higher concentration to the lower concentration, with the help of the pressure, with the help of greater extent of hydraulic pressure. So that movement is called as a reverse osmosis. Now the pressure is applied on the salt water side, so that the water molecules which is present in the salt water side migrates to the water side through the same permeable membrane with the help of piston, and the this pressure will be very greater. The greater extent of hydraulic pressure will be applied as compared with the osmotic pressure, and this results in the all the water which is present in the salt water will migrate to the water side, and the salt will remain in that compartment, but not the salt will not migrate to the water side. So this movement of water molecules present in the higher concentration, that is in the salt water side to the water side, is called as a reverse osmosis. You can easily see from the figure there is a greater extent of hydraulic pressure will be applied with the help of a piston, so that the water molecules present in the salt water which is at the higher concentration migrates to the water side through the semi permeable membrane. So that movement of water molecules with the help of a greater extent of hydrostatic pressure, so that movement is called as a reverse osmosis. Now during this reverse osmosis, advantages. So reverse osmosis, it is quite economical, and it's a simple process, and it is a continuous process, and it's a compact process. So simple to operate. Only you need to apply greater extent of hydrostatic pressure on the water, on the salt water side, so that the water molecules present in the salt water side migrates to the water side, and the process needs to be extremely low energy. There is no much energy requirement, so it has a long life, and the membrane is easily replaceable. So once the membrane pores will saturate with the salts, the membrane need to get regenerated, and it can be easily replaced. So the membrane can be easily replaceable, and any kind of solutions, like solutions of ionic solutions, or maybe colloidal solutions, or maybe high molecular weight organic matters can be easily removed. So the water molecules which is present in such solutions can also be easily removed with the help of this reverse osmosis process. So that is the advantages of reverse osmosis. Now the few of the disadvantages also. So disadvantage is that when such a forceful movement of water molecules from water side, from salt water side to the water side takes place, usually that water will be acidic. And second disadvantage is that colloidal silica is not removed by this process. So the silica which is present in the saline water in the colloidal form will not be removed by this process, and some critical contaminants are not removed. It's like some volatile organic compounds, volatile chlorines and chloramines. Such some critical contaminants, if at all present in the saline water, will not be removed by this process. So these are some of the advantages and disadvantages of the reverse osmosis process. Thank you.